Here we're going to look at the evolution of operating systems. So we understand a little bit of the history. So the history of operating system runs mostly in parallel with the history of computers. So let's look at all a little bit. So first, when we had computers, they would run one program at a time. And these programs were stored on punch cards. You can see an example here on the slide. And these cards were fed to the computer. So while this program was running, it had complete control over the computer and no other program or task could be executed at the same time. So on these systems, there was basically no operating system. So in the 50s, computers evolved a little bit and were able to perform some concatenation of tasks. And these concatenation of tasks were called jobs. So the idea was that programs that were similar would be grouped together in a batch, and then we could reuse resources. So for example, a group of different programs in Fortran could be grouped in a batch. And then the Fortran compiler only had to be loaded in memory once to compile and execute all of them sequentially. So we could reuse the fact that we had to load the Fortran compiler. So to schedule the execution of these different programs, we would have a monitor. And this is actually what is the predecessor of first operating systems. So, and actually these schedulers that schedules all the jobs can be considered the core of what are operating systems nowadays because they control how other programs can be run. So next steps in the evolution of operating systems was to allow several users to access the computer interactively. So this was done by using remote terminals that were text-based interfaces with a keyboard and a screen without processing power. And that would allow people to access to the mainframe of a central server. So here we see an example of a terminal with a keyboard. And this would just connect to the mainframe or a central server. So in this interactive environment, multitasking and also multi-programming led to even better utilization of the computer resources. So because, for example, imagine that somebody is inputting text or data. If you input text or data, the CPU is basically idle, it's not doing so much. So during this time, we can give this CPU time to other users that can do other things which does require CPU cycles. So in this way, we can reutilize and manage the utilization of the CPU and share effectively the main processor between multiple programs and multiple users. So an important fact in the history of operating systems is the arrival of Unix. Unix was started by a group of developers, researchers of the Bell Labs that abandoned the Multics project. And Multics was a project, it stands for Multiplexed Information and Computing Services. This was a project for developing a time-sharing operating system that began at the MIT Research Institute in 1965. And although this project was failed and researchers abandoned the project, this was actually a very important influence on operating systems development. So the developers from this project started working on another, more simple and more modular system, which was Linux as we know it nowadays. And differences was that they wrote it in a high-level language and not an assembly code, and that it was modular, so it was based off different modules, and it was actually the base of what we know as modern operating systems nowadays. So then, an important step in the development of operating systems and also computer science as a whole was the arrival of personal computers. Because the arrival of personal computers actually changed the orientation of what an operating system is. Because an operating system went from a tool that is only available to experts to a more friendly environment for domestic usage. So operating system development changed because the requirements and the goals of what is an operating system changed. For example, it now had to perform and be able to run on inexpensive hardware, like compared to the expensive mainframes, because now it could run on personal computers that people could just have at their homes. And we needed standardization that was allowed that would enable us to use operating systems for different types of hardware. So associated with the appearance of personal computers is the appearance of graphical user interfaces, or GUIs, and the use of a mouse. So these were completely new ways to interact with a computer instead of using the command line and just a keyboard. And Xerox Alto was the first machine that had a graphical user interface and a mouse to control it. And this is actually has been the basis to the way we interact with computers nowadays. The thing behind Xerox Alto and a graphical user interface is that it uses abstractions and metaphors to represent written commands. So we have windows, we have pointers, we can move things around, and we have menus and all kinds of things that we use as an abstraction to understand the commands that we want to execute. So this was a great success, and it turned out that pointing devices and graphics on a screen were a very useful way to interact with a computer because they're very intuitive to users and very easy to use. So with the use of these interfaces that made it even more easier to use computers, became the widespread use of personal computers at people's homes. So the main actual trends in operating systems are obviously related to smart mobile phones. And this can actually be considered a revolution because now we have small operating systems that are directly stored in the memory of a mobile phone. And it's a revolution with respect to the interfaces because also these are different. It's now based on tactile control, which obviously is a different way to interact with an operating system than a mouse. And it has to be designed for small screens. So this also means that we have to change the way we interact with an operating systems. Main mobile operating systems for different types of devices are iOS for Apple devices, Windows Phone for Microsoft devices, and Android, which is basically the mobile variant of Linux. So how is the future going to be? So in the future, the way that humans interact with computers will change. We already see some techniques popping up nowadays, like for example, voice control. We can control our phone with voice. And this is being done by using speech recognition techniques to be able to understand what the user is saying to start up some specific commands. And there's things like virtual reality. Virtual reality replicates an environment that simulates a physical presence in the real world or imagined world, and makes users enabled to interact with this world through sight, hearing, touch, and even smell and taste. So in the future, it's foreseen that there will be many different ways of using computers, even with the mind, for example. In the future, it's foreseen that we will move the mouse by just thinking about it.